There we go.
All right, cool.
All right, so number 2, I'll start. Which of the following variables is categorical? So it'd be the middle one there. Brand of toothpaste.
Let's see. Hold on a second. Okay, let's see. Yeah, I got it. So that's the randomly selected brand of toothpaste.
Yeah, because it doesn't have anything to do with numbers.
All right, so number 3, the mean IQ test score in the United States is 100. 20 random selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is true? I actually got this one wrong.
Yeah, at first it kind of threw me off because there's technically 3 numbers there: 100, and then 20, and then 112. But they're obviously only wanting 100 and 112. So the parameter is the entire population, and then the statistic would just be the
112.
Yeah, exactly. It'd be the mean.
Okay, so the population's 100 and the statistic is 112.
Yeah, the parameter.
See, I think I got it.
Mixed up.
Confused. Yeah.
Yeah.
So it's 100 is the parameter and 112 is the statistic.
Exactly. Yep. Number 4, Rotham City has 4 distinct neighborhoods. Property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to proposed increase in property taxes? So we're going to want to take both, or we're going to want to find, the low property value, or the low income, I guess, versus the high. So that'd be 2 different groups. So I said stratified.
Yeah, that's what I got. I guess that's the one I put 2, and it was right. So
yeah, same.
Yeah. I mean, that one made sense.
Right.
Like, that one wasn't too hard. All right, 5. Let's see. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly selected teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? All right, I guessed on that one. I was saying systematic, but I was wrong.
Yeah. So I actually got it wrong too. I think I said stratified, but I went back to the reading, and it's actually a cluster.
Is it?
Mm-hmm. Yeah, because the cluster says is all items in one or more randomly selected clusters or blocks. So they used all the kids in the class from that cluster, that class.
Oh, okay.
Pretty sure that's.
Yeah, it sounds right.
Number 6, at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? That's a simple random sample.
Right. Let's see, number 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? And that one is stratified random sample.
Yep. That's what I got too. Okay, so then we're using the Excel spreadsheet. Were you able to get that figured out?
Yeah, that's pretty much self-explanatory.
Right. So you just use
So
that to get the mean. Let's see. So the mean was 4.771.
yep, that's what I got. And then the standard deviation was 1.912.
Let's see here. Then we create a histogram.
True.
Right. For that, how did you end up doing that?
Um,
I don't know if I did it right. I created a bar graph.
I just created went and how in Excel you can create,
Right, a graph.
Yeah,
Yeah. So
that's what I did. So I don't know if that's exactly right, but
right. I think that's right because there weren't well,
there's not an actual histogram you can create, but I don't know.
I don't know either. That one was kind of confusing.
Mm-hmm.
I don't know what they're gonna have us do on the exam for that one, but I guess we'll just move on.
Yeah. All right. So this one, it was the body temperature of the seals. So they placed thermometers inside the seals and saw what their body temperature did. So 11 was the value of the number that goes in the position marked A. So that was, let's see, he subtracted the representative temperature or whatever.
From
the mean. And you subtracted the mean from that, and that's what A was.
Yes.
And that was, let's see.
I got negative 0.165.
Yeah, that's what I got.
Now, actually, when I first did it, I rounded the
6.
The mean. Well, I rounded the mean though, so I got because the mean is 38.075, so I was using 38.08.
Oh,
so, yeah, so it wasn't giving me. So I actually got that one wrong the first time, but I'm pretty sure it's negative 0.165.
Well, I put I got it right, and I put negative 0.165. I don't know if that makes a difference, but
wait,
if you add the 0 or not.
Negative 0.0165, or
I mean negative 0.165.
Okay, I guess I'll do that.
And that was right, so maybe just put that just in case.
Yeah, I think I will. Okay, number 12 is B. Where'd my phone go? I should have wrote these down. Actually, I did write them down, but since I was using the wrong mean, I didn't write the correct ones down. So that's 37.25 minus 38.075. Or, sorry, oh yeah. Okay, so that'll give you the deviation, which is negative 0.825. And then you just square that, and that should be...
I got 0.681.
Yeah, that's what I got. There it is.
Okay, good.
Okay, next one.
All right. So what quantity is equal to the sum of the numbers on the square deviations column, and that's none of them?
Right. That one threw me. I had to go back to the book and research that. That was... I thought surely they wouldn't throw us off by saying it's none of them.
I know, huh? You never know.
Right. Okay. What is the standard deviation of these temperatures? Did you do it by hand?
Let's see.
Because I use Excel, but I know how to do it by hand.
I don't. I think I just use it. Actually, I did do it by hand. I did do it by hand.
So
Well, you know what? I use Excel too. You're right.
I got 0.715.
715. Yeah.
Yeah. So I think because that's where I researched. So you just add up all the square deviations, and then you take. What was it? It's in chapter 3. You take like it would be the number of samples minus 1, and you take the sum of those deviations divided by that, and then you take the square root of that number. It's pretty involved.
I love Excel.
Right, exactly. But that's, yeah. Let's see. So then, are we on question 15?
Yeah.
Under certain conditions, the standard deviation can be negative. That is false. Always be positive. Okay, 16.
All right, 16. So I'm not going to read the whole thing.
Yeah.
But which location resulted in the most consistent temperature measures from one seal to another? And obviously, it's the extradural because it has the least amount of or the smallest standard deviation.
Right.
So.
Yep, which means that the data would be closer together. Okay, 17. Third quartile is 8.
Yep. All right. What percentage of the data lies between 4 hours and 8 hours? Let's see, that one is 50%. Just 50.
Yep. Let's see here. Where are we at? 19. So we are estimating the mean of the nitrate concentration. So I just took those two numbers, the 1.59.
How do you find that? I got the right answer, but I'm not even sure how I got it.
I know. I wasn't sure if I was doing it right, but I just took the mean of, it said that it would be between 1.59 and 2.52. So I just took the mean of that. So I took 1.59 plus 2.52 divided by 2.
I guess that makes sense. Yeah.
2.055.
Yeah, that makes sense. I mean, because it would be in the middle of those two,
right,
total. So yeah. Okay. Yeah, and I got 2.055. So.
And also, it said that values outside of this range are unusual, so we know that those are kind of the end caps for the 2 standard deviations.
All right, so this one, estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. That was the standard deviation was 0.233, and you just find that by taking the 2 point you can take like.
How did I do that one?
Well, you can take like 2.52 and subtract it from.
So I just plugged it into that equation there. I put the mean of 2.055 minus 2 standard deviation,
Yeah.
And then I subtracted.
Because that was 2 standard deviations. So then you just split, divide it by 1 or split it in half. And that would be 1 standard deviation.
Right. Yeah, I subtracted 2.055 or 1.59 minus 2.055 and then divide that by 2. And
Yep.
that gives you 0.233. Okay, 21. Between what two measured nitrate concentrations do approximately 68% of the data value lie? So that's 1 standard deviation away from the mean on both sides, which is 1.823 and 2.28.
Mm-hmm. All right. So I'm not going to read that whole thing. But what is the probability that a randomly selected student will score above the 542.3 on the GMAT? And it's 50%. Or 0.500.
Yeah. I don't think that one, I think I just put 0.5 and I got it right. So I don't think it mattered. What's the probability that a randomly selected student will score below 600? And that was a z-score of 0.479. So it was 0.684.
Yep. All right. All right. What is the probability that a randomly selected student will score 600 or above? Just take when I plugged it into the z-score, put it above or just shaded the area above on the probability applet. It's 0.316.
Yep.
So after finding the z-score and then plugging it in.
Right. You can also just do 1 minus.
Yeah.
Below, 0.684. 25. Find the GMAT score that corresponds to the 10th percentile. That would be rounding to the nearest whole number would be 388. So find the z-score, or actually, you have the z-score of, or you've got the area in the applet of 0.1. That gives you a z-score negative 1.282, and you just solve for the value.
Yep.
388.
So similar to that with the 26, but you're doing the 90th percentile, and that one was 697.
Number 27, similar thing, but for the first quartile or the 25th percentile, and that will give you 461.
Yep. All right, 28. The third quartile of the distribution. Let's see. 624.
Yeah, those ones, as long as you remember the z-score formula, pretty simple.
Yep.
Then 29, consider a simple random sample of 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples? Because the sample mean equals the population mean, if it's a normal distribution, which it is 542.3.
All right, so let's see. So the standard deviation of the distribution of the sample means scores for such samples. Since there's no sample size given, right? It's just
no, there is. Yeah, so it's still we're. What is standard deviation of the distribution of sample mean scores for all such samples? This one I thought we were. I think we're still using 15 students.
Oh yeah, you know what? I got it. You're right.
Yeah.
Yeah, so it's 15, and then it's anyway, you do the formula.
Yeah, it's the standard deviation for the population divided by the square root of
15.
15 or the sample
divided by the standard deviation or whatever, and that's 31.123.
Yep, what I got. And the last question: what is the probability the sample GMAT score for a simple random sample of 15 students will be greater than 600? So you just get the z-score of that sample. So you take the sample standard deviation instead of the population, and you that z-score is 1.854. You plug that in and find the area below or greater than, and that is 0.032.
Yep, 0.032.
Mm-hmm.
All right, let's submit this and make sure we got it all right.
Got it all right.
And we're good to go.
Perfect.
Sweet.
All right.
Man. You got any questions or anything?
I don't think so. I think after I went back and read through some of those sections, I think I got it.
Yeah, it's a pretty good review.
Yeah.
So, alrighty. Well, I guess we'll plan on Wednesday night.
Yep, Wednesday night for lesson 9.
Yep. So you have to take the quiz by Wednesday, right?
I think so. Yeah.
I think that's what it said. So.
Yeah.
All right. Cool, man.
Good luck with that.
All right. You too. We'll talk to you later.
All right. Bye.
All right.